Welcome back. So we've just learned about the first two, well, kind of three, because we also mentioned that there is such a thing as a complex number in Python. But we talked about the main ones, the int and float, and there are still a few data types remaining. But before we get to these, we are missing an important concept. And this is going to be our first important term in Python, and as a matter of fact, in all programming languages. It's called variables. Yep, that's a term. Now, if this is your first time learning a programming language, you might not know what this means. If this isn't your first time, well, this is very simple because all languages have variables. But what are they exactly? Well, variables store information that can be used in our programs. So we can hold perhaps user inputs like values. Maybe when you log into Facebook, you need to hold some information such as your profile picture or maybe your date of birth in a variable. Variables are ways for us to store information on our computer. So let's have a look at this. If we remove this, and let's say I'm creating a quiz program. And this quiz program maybe measures your IQ. And let's say you just took the quiz and you found out that your IQ is 190. Quite high, good job. But we need to store that information somewhere. Well, we can do that with variables. So that in Python, all we need to do is name it whatever we want. In our case, it'll be IQ. And we're going to say IQ equals 190. And this IQ here is a variable. It is something that I just completely made up. I could name it whatever I want. That's a variable too. The idea is that once we assign to a variable, that is, we're saying 190 is going to be assigned to IQ, I can now use it in my program whenever I want. For example, I can later on print, or make sure it's not cap, let's do print IQ. And if I do that and click run, you see that I can use IQ. So we can pretend here that a user takes a quiz, finds out their IQ is 190. We can store that information in this variable, and later on, when they come perhaps online or try to use the program again, they don't have to take the quiz all over because, well, we store that information in IQ. And remember what I said at the beginning. Programs are simply data that's being stored, that's being changed, that's being removed, and that's all programs are. And variables are important concepts in Python and all languages. Now, variables can also sometimes be called names. So this could be a name, for example. And assigning a value is also known as binding. That is, we're binding the value 190 to this variable so that when we request this variable later on in our program, our computer knows how to look for this information. It's going to say, hey, I know what IQ is. I stored it somewhere in memory. And it's going to go look for that. And because it's being bound to a value, it points to this value, 190. And remember, this number in memory gets stored as a binary representation in zeros and ones, right? But it doesn't matter to us because however our machine stores it, we don't care. We just want to be able to retrieve it. And then when we print it to do, well, get 190. Now, we're going to be using variables all over the course. But on top of just naming variables however we want, there's some best practices around variables of how you should write good variables. And as a matter of fact, these are specific rules that the Python community as a whole has that you'll just have to remember. So let's have a look at this. Variables, and remember, this is the symbol for best practices, are what we call snake case. Snake case means it's all lowercase and then spaces, well, they don't exist. We use underscores. Variables must start with a lowercase or an underscore. Variables can be anything with letters, numbers, and underscores. But remember, they have to start with lowercase and underscore. That means we can't start a variable with a number. They're also case sensitive. That means if I create a variable, but let's say this snake case, this variable has a capital E instead of a lowercase e, that'll be a different variable. And then finally, you can't overwrite keywords. Let's go through these with some examples. First, a variable has to be in the form of a snake case. That is, if I want to call this user IQ, I should technically have an underscore here instead of a space, just to make sure that a programmer, maybe I'm working on a team, can read this variable. So that's snake case. You also have to start your variables with either a letter or an underscore. So I can technically do this. And I click run. Well, that's going to give me an error because I've changed the variable. So now in order to access that variable, you have to go like this. Now, underscore in Python signifies a private variable, something that we'll go over later on in the course. But usually you're starting your variables with a letter. And afterwards, yeah, you can add numbers if you want in here. That's no problem. This is still going to work. This is a valid variable. Finally, a variable is case sensitive. So if I do user IQ here, and I do capital letters, I can't access this like this because, well, it doesn't exist. Again, it's case sensitive. We have to make sure that we match. And finally, we don't want to overwrite keywords. What does that mean? Keywords in Python, well, they already mean something in Python. For example, this print is a keyword. You can see it highlighted in blue. So that if I create a variable saying print equals 190, and then I do print, let's see what happens. We get an error because I can't really assign to this variable because print already means something. Now I know what you're wondering. What are these keywords in Python? That's a simple Google search away. And we'll learn these throughout our course. If we go to Python Keywords by E3 Schools, you'll see that we have these keywords that each mean something in Python. Again, we'll go through these and we'll learn them throughout our course. And if you look, it's not that intimidating. There's not that many. So as we practice, you'll start to get familiar with them. But the easiest way to tell whether it's keyword or an important word in Python, well, you see that it's highlighted in blue. As soon as you create a variable that is unique, it's highlighted in white. And this will be the case with whatever environment that you're typing code into, as long as it's set up for Python. Now, beyond the Python keywords, there are different things like, for example, the int for integer that we've learned. So these we're going to get familiar with. So a good rule of thumb for variables is to make them really descriptive. Really say what your intention is. And a good programmer is somebody that's able to name things really well with their variables. So if a new developer comes and looks at your code, it's easily understood. Finally, variables can also be reassigned. For example, let's say we have IQ here of 190, and then I decide to perhaps have another variable, call it user age. And for some reason, I want to assign user age to perhaps have IQ divided by 4. Is that going to work? It should, right? I'm saying user age is going to equal 47.5. I'm using IQ, which is 190, dividing it by 4, and then assigning it to user age. I can maybe assign this to another variable called user age or called A. And once again, I run this and it's printing the same thing. So you can use variables to store that information and use it whenever you want. You can use it in operations, you can use it to reassign it, whatever your program needs. Now, later on in the course, we're going to learn about classes, and classes actually have a different convention than this, but we'll get to that later on. For now, though, I want to mention two small gotchas with variables that you should be careful with. For example, there's an idea of constants, and constants are those things that never change in a program. For example, if we wanted to create a constant, such as the value of pi, let's say for now it's 3.14, we can have it all in capitals. And that's going to tell other programmers that, hey, this is a constant. This number is not meant to change. I mean, we could change it if we want. There you go. I just made pi equal to 0. So it was stored as 3.14 in memory, but then we overwrote it and reassigned it the value of 0. You can still do that, but a good convention is that if you see this, that means this number or this value should never be changed. Another type of variable that you're going to see, and this is something we'll see later on in the course, are it doesn't look like I just did double underscores here, but it's 2 underscores, and we call these dunder. And as you can see here, we have some dunder variables that Python has. Now, we'll learn more about these later on, but the idea here is that these are meant to be left alone. You should not touch them. You shouldn't create a variable with 2 underscores like this and call it hi and assign it a value. I mean, you still can, however, this is generally not good practice. So you want to be careful with that. But the one thing that I really want you to take away from this is that variables are really important concepts in programming. Naming variables is one of the most important skills you have as a programmer. I know it sounds silly, but there's so many times that I read code that is so hard to understand simply because a programmer is not descriptive enough. So throughout the course, we're going to learn how to name things well so that our code reads like English. And that's the whole point of writing good code. The point of writing good code is that it's readable and understandable by other programmers. By the way, to finish off, I just want to show you one quick trick. There's also a way that you might see in some code bases that uses something like this. Equals 1, 2, 3. And this simply is a way for us to rapidly assign values to variables multiple times. So for example, if I do print A, then print B, then print C, and I run this, you see that I get 1, 2, 3. We assign value of 1 to A, value of 2 to B, and value of 3 to C. Just a quick shorthand way that you might encounter. All right, let's take a break, and I'll see you in the next one. Let's learn another important key term. Well, 2 for that matter. One is expressions, and the other one is statements. You're going to hear this a lot when talking to programmers. So what do they mean? Let's have a look. If we create a piece of code here, let's just say IQ is 100. IQ has lowered. And then let's say user age is going to equal IQ divided by 5. An expression is this part of the code. It's a piece of code that produces a value. In our case, this produces a value, right? Because 100 divided by 5 is going to equal 20. So this is an expression. A statement, on the other hand, is an entire line of code. Not this entire thing, but an entire line of code that performs some sort of action. In this case, what action are we performing? Well, the action is that we're calculating 100 divided by 5 and then assigning that value to the variable user age. So this is an expression. This is a statement. And also this is another statement. So if you hear me mentioning these terms throughout the course, hopefully now you know what they mean. I'll see you in the next one. Bye-bye. Welcome back. I want to quickly talk about something called augmented assignment operator. So we've learned that we can create variables like some value, and we can assign it a data type. In our case, let's just assign it 5. There's something called augmented assignment operator that allows us to do something quite neat. Let's have a look. So if this value, I want to increase it, let's say 5 plus 2, so add 2 to it, I could do that. Or I could even use some value which is already 5 by the time it gets to line 3 and do something like this. If I print some value and I click run, I'll get 7 because 5 plus 2 equals to 7. So in memory, some value points to 7. But there's a neater way of doing this called augmented assignment operator. Instead of doing something like this, I could just simply add a plus to the equals. So we're going to say some value plus equals 2 is still going to equal 7. So it's the same thing as before. And this is called augmented assignment operator. It's a shorthand of us doing something like this. We can also change this to something like minus, which once again is like subtracting 2 from whatever the previous value of some value was. Now, if I was to do this at the beginning here, so let's just do here and then comment this out. And if I click run, I'll get an error because some value is not defined. We haven't really created anything. So in order for this to work, we need to make sure that this variable has some previous value. So we've learned about the plus, the minus, and then finally we have the multiply. Once again, if I run this, we get 10. Remember, this is just the same as us saying some value times 2. It's just a shorthand form. All right, this was a quick video in case you see something like this in the wild. Now, you shouldn't be afraid. Remember that the operator comes to the left of the equal sign. I'll see you in the next one. Bye-bye. All right, we're almost kind of flying through this. I know we're going slow here, but trust me, once you get these data types, things become a lot easier. So we're just climbing that mountain so that we can start looking at a higher level at the language of Python. To keep going, let's talk about this data type, str, which stands for strings. Let's see what they are. A string is simply, well, a piece of text. For example, a string can be written with quotation marks. And I can say, hi, hello there. And that is a string. You see that the color changed here in my editor. I can also make strings with double quotes. So once again, this is also a valid string. And I can put anything I want in here. I can do numbers if I wanted to, exclamation marks. It's just a piece of text. You can think of it as a sentence for now. And if I do the type function here, remember, these brackets denote that we want to perform some sort of action, which is we're using the type action that Python gives us. And if I click run, you see that, and remember, we have to print it out as well. So let's do print so that we can see the display. And I click run, you see that it's str. It's a type of string. Now we can use this in important ways. For example, imagine you're creating a login form and we want to collect somebody's username and password. Well, we can have username variable that we assign, let's say, some sort of username. Let's call it supercoder. And then password can be super secret. And now we have these variables, usernames and passwords that we can use throughout our program, such as to check if a password exists. And remember, I can use single quotes or double quotes. But there's a third way that we can write strings in Python. And this, well, is used for long strings. So let's just create a variable long string. And what we can do here is 3 single quotes in a row, like this. And then here, I can just say, wow, maybe a pair of eyes of somebody that's really impressed, and let's go with a mouth. That actually kind of looks like hair. All right, and then I finish it off with 3 single quotes again. So now if I print the long string and I click run, look at that. My little weird emoji face is printed. So the 3 single quotes is for long strings that I can keep going on multiple lines. For example, I can't do this with the single quote. You see that the orange color is now gone because Python is going to say this is a new line and this is another line. And it's going to give me an error because, well, a cret with a quote doesn't mean anything. But if we use 3 single quotes, you can see that we can do multi-line strings. And this is really useful if you want to have maybe long sentences and paragraphs. Now, with a string, we can do some cool things that we saw in the numbers videos. What if I had something like this? Let's say I wanted to grab the first name of a user. Just give my own name here, and then last name. And again, my super hard to pronounce last name. Could we do something like this, where we have full name equals to first name plus last name? And then if we print here the full name like this, should this work? Well, let's have a look. Let me remove this part over here just so we have nice and clean looking code. And if I click run, there you go. My name is printed, but you see that there's no spaces here because we're going to use the addition sign to attach Andre to Nagoye, but you can see that there's no spaces here. So I can add a space if I wanted to, or I can just simply create another string inside of here, just like this, and then add a space in between. So we're just using the plus sign, which we've seen in the numbers videos, but instead to add strings together. And now if I click run, you see that I got the space because I'm adding a space in here, in between the names. Very, very cool. But there's a few more neat things that we can do with strings. So let's welcome back. I want to quickly touch on the subject of what we call string concatenation. Yes, programmers love creating really complex names when concepts may not be as complex. So what does string concatenation mean? Well, it simply means adding strings together. So I can do hello plus Andre, and I've concatenated the string. I've added 2 strings together. So if I print this, I get hello Andre. So if you ever hear people talk about string concatenation, that's what they mean. We're concatenating strings. By the way, what do you think will happen if I do hello plus 5? If I click run, that's not good, is it? I get type error. Must be string, not int. So it looks like string concatenation only works with strings. We'll explore that a little bit more in the next video. Welcome back. Remember in Python that string is written as str, and this is a special word. Actually, it's a built-in, what we call function, or built-in action that we can take. Now, let me ask you this. What happens if I do string 100? 100 is clearly a number, an integer. But what if we run the string function on this? Let's find out. Let's do print here and then run this. If I click run, I get 100. All right, but is this an int or a string? To find that out, once again, let's wrap this, so the answer of whatever this value is, into type, like so. I know this is a lot of brackets, but remember, we're evaluating this piece of code. So we're turning 100 into a string or running the string action. And then we're going to check the type of this entire thing. And then we're going to print it out. If I click run, I see that it's a string type. So we've converted 100 into string using this. Now, just to confuse you a little bit more, what if we do something like int? Like this. All right, even more brackets. What happens now? Can you guess? Well, we convert 100 into a string, then convert it back into an integer, and then we check the type of it, which is a class int, and then we print that. So remember, this was the same as me saying a equals str 100, and then b is going to equal int of a, because we're evaluating this part. And then I'm saying c is going to equal the type of whatever b is. And then finally, we're printing c. So that piece of code was the same as doing this. Very, very cool. Now, this is the idea of type conversion. Again, if I were to write that down, it's called type conversion. We're converting the type of our data types. And you can do that throughout programming. And we'll talk a lot about this throughout the course. But it's the main reason we have things like str, int, we have things like float, and many other data types that we're going to talk about. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about something called escape sequence in Python. Let's comment this out. And let me ask you a question. What if we wanted to have a string that tells me, let's say, the weather? And here we want to write, it's sunny. You see how the highlighting changed here? Because I want to say it's with an apostrophe s. But Python is reading this and saying, okay, this is the start of the string and this is the end of the string. And then I have no idea what this is, and then we're starting a string again. How can we fix this? Well, we can add a double quote string instead, and this now works. But what if, for some reason, we also wanted to add it's kind of sunny in quotation marks? Well, now we have another issue. So how can we solve this? Because in human language, we have double quotes and apostrophes. Well, we can use escape sequences here. And this is a little hard to understand at first, but it's simply adding a slash like this. So the one right above your enter on the keyboard. So this slash, when Python goes through it, is going to say, all right, whatever comes after this, I recognize this symbol. Whatever comes after this, I'm going to assume it's a string. So now if I do backslash here, and then backslash here, it's going to say, hey, Python, I'm letting you know whatever comes after this is a string. I'm letting you know whatever comes after this is a string. And then I'm letting you know what comes after this is a string. So that when we print the weather, everything is printed nicely. Awesome. Now, this escape sequence can be used in multiple ways. For example, if I want to have an actual backslash, well, I can go like this. And because it's saying whatever comes after this is a string, it's going to assume that this is a string now. So if I run this, you see that we get this backslash. And there's a few other neat tricks that you can do with it. For example, one of it is the backslash T. What does that mean? Well, let's remove this for now. There you go. The backslash T, remember, let's add a space in here so we can distinguish it, is going to say, hey, whatever comes after this, I want you to add a tab. This is a special meaning here. So if I click on run, you see that it's added a tab spacing to my string. Another one is using n, or a new line. So let's leave T here and then add a backslash n and then say, hope you have a good day. What do you think will happen here? If I click run, I have a tab from the backslash T, and then I have a new line after kind of sunny because I do the backslash n, which denotes a new line, so that this shows up on a new line. Now, these escape sequences are hard to see at first, but they're pretty much available in all programming languages that use strings. So if you come from another language, this shouldn't be that strange to you. If it's your first time seeing this, you just need to get used to this syntax, and every once in a while, go to the Python documentation and just type in escape sequences, and you'll see all the ones that we have. These are the main ones that you need to know. All right, more to learn in the next video. Welcome back. Let's talk about the topic of formatted strings. Up until now, we've just written simple strings. But we want a program that's dynamic, that's static. Let's say we have a Amazon page, and we're working at Amazon actually. And when a user logs into their profile, well, we want to display their name or what they have in the cart. In that case, we don't want to just hard code and write every single user's name, like Andre, or another user, Joe, and write every single name in the world. No, ideally, what we can do is have something dynamic, where let's say it's a profile page and we simply use the name variable and we display that on the page. Now, this name variable should equal whatever the user's name is. And this is something that we can grab from the database, again, something that we'll talk later on in the course. But let's assume that in here, when we do equals, we're going to grab some user information, which will be the name. And this name, for now, will be John. Or let's go Johnny. And this Johnny, we want to display on the profile page. And we can do that with formatted strings. We can simply do something like print and then say name. But we also want to greet that person, right? So let's do hi and then plus name. And remember to add a space. If I click run, I get hi Johnny. But as we get more and more information, let's say we have age and Johnny is 55. If I wanted to extend the sentence and I want to say you are, and then add another plus, make sure we add a space in here, and then add year old. Run here. All right, we get a type error. Must be string, not int. Oh boy. All right, so we have to convert this into a string. So remember, we can do that like this. And then if I click run, hi, Johnny, you are 55-year-old or years old. All right, that was a little cumbersome, but we're making our Amazon page dynamic. We can grab different information from the database and we'll have in a string something according to the user. But there's a better way of doing this. And with formatted strings, all we need to do is add an F at the beginning. And this F at the beginning is going to tell Python, hey, this is going to be a formatted string. And instead of doing all this plus and name and all this stuff, and doing the str to convert the type, we can simply do something like this. Let's remove this and simply do brackets and say name. And then again, remove all of this and say age. So I'm going to say, hi, name, you are age years old. And if I click run here, you see that it still works. This is a new feature of Python 3. By adding F to the beginning, it's saying, hey, this is going to be a formatted string. And I want you to just make these variables available as strings inside of, well, this string. How much cleaner is that? Now, although this is nice and clean, and this is my preferred way of writing strings, before Python 3, you didn't really have this. So in Python 2, and mind you, this works in Python 3 as well, as you can see, we had something different to accomplish this. What we had was this idea of a dot format. And dot format, so let's remove the F here, is going to do the same thing for us. We do a bracket here, and then we say, hey, we want Johnny and age of 55. And we can just remove these variable names. If I click run here, I get an error. And you have to be careful here. Dot format works on strings, but you can see over here that we did it outside of the brackets. And what it's doing is saying, hey, run the format action on this print. But print is not really a string, right? So you have to make sure that we move the brackets to the outside so that we evaluate this piece of code first. So the string is going to get formatted, and then we're going to print. If I run this, hi, Johnny, you are 55 years old. So that works the same way. But what if we wanted to use variables? Because right now we're just doing this by order. So whatever comes first gets filled in first in the brackets. Well, we can do something like name and age. Let's see, can we do that? Let's run. There you go. That works the same way. What if we had a specific order? Maybe we want this to be age and here to be name. Well, we can mix those around. We can say 1 here and 0 here. Because in computer science, we always start counting from 0. So this is 0 and this is 1. If we had something else in here, let's say a third variable, then this will be 2. So if I click run here, all right, everything is upside down. Finally, I can just create my own variables if I wanted to. So let's say hi, let's say new name equals Sally. And then age of Sally is going to equal, let's say 100. Sally is very old. Now, if I do 0, let's say I'm 1 here, if I click run. So now we'll actually get an error. Tuple index out of range. Now we haven't really learned about tuples and ranges, and this is a little confusing, but a bit of a trick here. We want to make sure that we add now, because we've given the actual variable a value, we need to actually say new name here. And here will be age. So that if I click run, there you go. Hi, Sally. You are 100 years old. As you can see, with dot format, things are a little bit more complicated. You'll still see this, and all Python 2 code still uses the dot format. And you'll see a lot of Python 3 code bases that still use dot format because some people prefer it. But I would argue that the F at the beginning of a formatted string is the way to go because, well, it just makes things so much easier, right? Nice and clean, nice and easy. So I do recommend that you use the formatted string with the F in front. And for short, we usually call this an F string. All right, I'll see you in the next one. Bye-bye. Now, up to this point, we've learned that str is an ordered sequence of characters, right? It's essentially a piece of text where we can write our names, passwords, paragraphs, and sentences. And strings underneath the hood are stored in memory, as I said, as an ordered sequence of characters. So for example, if I had the string me, then this will be stored in our computer's memory in an order. So M will be stored in a place in memory, and after that place in memory, E will be stored, then the space will be stored, and then M, then E, then space, then M, then E. So if you think of a bookshelf, each one of these is ordered in a different part of the bookshelf, but one after another. And the way we can think about this is like this. The M is stored in location 0, and then E is stored in location 1, and then space is stored in location 2, and so on and so forth. And each shelf now corresponds to a value. So that when we ask the computer, hey, I want you to grab this string, we know that, hey, we're going to look in the shelf 0 to 7. Now, why is this important? Because one of the most useful things you can do with strings is to access different part of a string using its what we call an index. So for example, when you have a string, and let's call this variable or this piece of string selfish. And selfish has me. And I'm going to comment this out just like this. Make sure it's aligned, okay? And what I'm going to do here is I'm going to say selfish and then square brackets right here, and then type in 0. Now, if I print this and I click run, check that out. I get the letter M. Why is that? Well, using the square brackets, I'm telling the computer, hey, grab the variable selfish, and then from that variable selfish, grab whatever is an index of 0. And what's on that bookshelf of index of 0? Well, the letter M. What if I do 7? What do you think will happen? If I click run, I get E, because on the bookshelf of number 7, that's E. And when I'm getting just selfish, I get the entire string. It's going to say, all right, I'm going to grab from the bookshelf index of 0 all the way to 7. Very, very cool. And this concept we're going to explore throughout the course, and you're going to see why it's important very soon. But using this knowledge, we can do a lot of string manipulation. And Python has this unique feature that we're going to talk about right now that allows us to grab different pieces of text. So let's have a look here. The rule here is when we use square brackets in Python, the first item that we put between the square brackets is what we call the start. The start is, hey, where do you want me to look? In our case, we said we want to look at 0, so we got M. We wanted to look at 7, we got E. But then there's an extra thing that we can do. If we do a colon here, we also have the option to say, hey, where to stop. What does that mean? Well, if I do something, and you know what, let's change this to 0, 1, 2, 3, 4, 5, 6, 7, just so it's easier to understand. if I do, let's say, 0, colon, 2, and I click run, I get start at 0, end at 2. So I get to grab 0 to 1. Because remember, I'm saying start here, but then stop as soon as you get to bookshelf 2. We don't want that. So if I do 0 to 7, what do you think will happen? Well, I click run, and I get all the way to 6. So in order for us to grab the full string, we have to do 0 to 8. Because there's actually 8 characters here, right? Because we start from 0. If I click run, there you go. Now there's a third thing that we can add here. And this is called the step over. And the step over says, hey, start here, and then step over a few things. So the default is 1 because we're going 1 by 1 through our bookshelf. You see that we get the entire string. But if I add 2 here, it steps over by 2. So I grab 0, then I step over 1, 2, grab 2, then step over 1, 2, grab 4, step over, and so on and so forth. So let me ask you a couple of tricky questions here. What happens if I do this? Is this valid? If I click run, what will happen? Ready to guess? I get 1, 2, 3, 4, 5, 6, 7. This says, hey, start at 1, so that is right here. But then afterwards, stop, well, there's nothing there. So the default is going to say go all the way to the end. I know this is confusing, but hang in there. Practice this often enough, and this will become second nature. Okay, what if I do something like this, where I don't fill the start and do 5 here? What happens now? Ready? I get 0, 1, 2, 3, 4, all the way until 5. So it starts as default 0 and goes to 5. Okay, what if I do something like this? 2 semicolons and then 1. If I click run, all right, I get the default behavior. Because it's starting at 0 when there's nothing. It ends whenever the string ends, when there's nothing, and then we're stepping over through it once. All right, but what if we do something like this? What if I do -1 here? This is a tricky one. What will happen? Let's find out. I get 7. In Python, the negative index means, hey, start at the end of the string. So that if I do -2, I get 6. If I do -3, I get 5 because I'm going backwards. And a neat trick that you can do here is if we do semicolon, semicolon, -1, and this is actually quite a common operation, so you just have to memorize this even though it looks weird. It means start, stop, there's no limit here, but I want to step over from the back. So what do you think will happen here? If I click run, do you see that? We get the reverse of the string. So this is a very useful notation if you want to, let's say, reverse an order. And if we want to, let's say, skip by 2, I click run, and you see that we're skipping by 2 now. Now, hopefully your head doesn't hurt with all this notation. You just have to get used to it. It's something quite unique to Python, but it's very, very useful. So up until now, we learned that strings can be accessed quite easily. And using the square brackets, we can access different parts of the string. And this idea of a start, a stop, and a step over is what we call slicing or string slicing, because we can slice the string however we like. But we also need to learn another important term that's going to come up again and again throughout this course. And as a matter of fact, it's an important concept that as you get more advanced into programming, you really need to understand. What is this concept? Well, it's this idea of immutability. It's an important term in programming. What does immutability mean? Well, strings in Python are immutable. That means they cannot be changed. What do I mean by that? Now that we've assigned selfish this value, this string, well, I can reassign it, right? I can say selfish is 100 now. And if I print selfish and I click run, that works. But if I instead do something like the first index of selfish is going to equal 8, and I click run, I get an error. I get a type error saying string object does not support item assignment. Why is that? Because strings are immutable. That is, I cannot change the value of this once it's created. I can't just immediately change it to 8, 1, 2, 3, 4, 5, 6, 7. No, it has to stay the same. The only way that I can remove this or change this is to completely reassign the value. So that in memory, Python removes all of this from our bookshelf of memory and instead just assigns 8 into the 0 bookshelf and removes everything else because we don't use it anymore. Now, this idea of immutability is something we'll explore more and more, especially when we start talking about lists. But for now, just remember that you can't reassign part of a string. Once created, it exists like that in that form. The only way we can change it is to create something new. We can do selfish plus 8, and we can create it that way. But now this selfish is a whole new string. This no longer exists, and a whole new shelf space was created for us to use this whole new string. Again, if this doesn't make sense to you or why it's important just yet, don't worry, we'll get there. For now though, I'll see you in the next video. Bye-bye. Welcome back. So far we've learned a few built-in functions that Python has. Few built-in actions, right? Actions that we can take on data. And we learned about str, we learned about int, we learned about float, and the type conversion that we can do. We also learned about type, we also learned about print. And these built-in functions in Python, well, there's a few of them, and I'll link to this resource, but there's not too many. As a matter of fact, we've also seen ones like ABS or round in our numbers video. So numbers had some functions that we can use, some built-in functions. Well, strings also has a very useful one called len, which stands for length. So as you guessed it, if I type in something like this and I print this out and I click run, I get 9 because it's calculating the length of the string. In our case, 1, 2, 3, 4, 5, 6, 7, 8, 9. The length of the string is 9. Now you have to be careful here because the length itself doesn't start at 0 as we've seen with indexes. Instead, it counts like humans do from 1. So a neat thing to do here is I can do something like this. Let's say that we have a variable greet that equals hello. Well, I can grab the greet variable, which is a string, and use string slicing to grab, well, the first and then go all the way until the end. Now the default already does this. If I leave it like this, it's going to grab hello. Oh, and make sure I add a bracket here. Let's click run. I get hello. Now, if I do 0 to length of greet. What does that mean? Well, if I click run, I still get hello because the length of greet is 9. Like so. Now, this length function is quite useful and we're going to use it a lot in this course. But I want to introduce to you the concept of built-in functions, as well as what we call built-in methods. What does that mean? A built-in function had this syntax of the word that was highlighted in blue, and then we used curly brackets to perform some action on a data type. However, Python also has this idea of methods. And methods are similar to functions, but they are owned by something. So for example, in Python, we have string methods. So these are methods or actions that only strings can perform. And don't worry, this is something that we'll talk more about when we talk about classes and functions. But for now, Python, for example, has string methods. So these are methods that we can use specifically for strings. And methods have a special syntax, where instead of just the word with the curly brackets, it usually has a dot in front of it. So dot, and then some sort of word, and we've actually seen one, format, right? Dot format curly brackets, or brackets, is a method. And if I go to Python string methods, and I scroll down or scroll up, we see that format specific values in a string, is a method. Now, why do we care? Well, with this, Python gives us automatic tools that we can use on strings. So let's explore some of these string methods. Let's create a quote here. And the quote is going to be or not to be. Now, in here, with this quote, we can use some methods on this string. Now, I'm not going to go through everything because, well, 60% of these you're most likely never going to use in your career. I'm going to go over the important ones that you'll see over and over again, but I'll also link to this so that you can see this for yourself as a reference. Remember, as a programmer, your job is not to memorize this and read a language like you read a dictionary. Instead, is to know that this resource exists and it's for you to explore and learn as a specific problem occurs. But let's get back to the task at hand. One thing that we can do is to use the upper method. We use a dot and then type in upper and then the curly brackets. And luckily for us, our editor shows us that this actually exists because of the drop-down menu. So what happens now? If I print this and I click run, look at that. Everything gets capitalized. To be or not to be. There is also another one we can use called capitalize. What's the difference between the two? Well, if I run, you see that it capitalizes the beginning of the sentence. And by the way, your editor, or in our case our REPL, if you hover over this, it'll actually tell you what it does. It returns a capitalized version of S. So whatever is to the left of the dot. And a good editor will actually show you all the things available to you. So as soon as you press a dot, look at that. I see all these purple boxes, which are methods that are available to me for a string. And you see there's a lot of them. Now, don't worry about these double underscores, these dunder methods, because this is something that we'll talk about when we talk about classes. But you can see that you have different things that you can use. For example, you have lower. Instead of upper, it lowercases everything. What if I want to use find, for example? And find simply says, hey, does B exist in the code to be or not to be? And if I click run, well, it tells me that, yes, quote.find has B, and it starts at index of 3. So if I go to 0, 1, 2, and then look at that, 3. So we have find, which finds us the first occurrence of a piece of text. You also have things like replace, where I can replace whatever I give it as the first thing, and then separate it to the second thing. So you can see over here, it tells me old, and then comma, new. And I can replace this with me. If I click run, I get to me or not to me. So this replaces all the occurrences of B. Now, the final thing I want to point out to you is that if I print here, quote, what do you think is going to happen? I've printed here and I replaced to me, to be or not to be with to me or not to me. Quite a selfish quote. But if I print this again on the 5th line, what do you think will happen? Let's find out. Whoa. Is this what you expected? Think about why this might happen based on what we've learned. Here's the thing. Remember, strings are immutable. That is, they cannot be changed. We can overwrite them if we want, but we don't change them. We either create them or destroy them. In our case, when we do quote.replace to me or not to me, it's creating a new string. Now, we're not assigning this string to anything. So eventually after we print it, we remove it from memory. But if I do something like this, where I have quote 2 equals quote.replace, and I print quote 2, well, in our case, we're creating a whole new string. We're creating a string, but we never modify the original string because it's immutable. So that quote always stays the way it is. Until we destroy it, until we remove it, our program ends, this is going to exist. All right. Hope you're having fun. Hang in there. More to learn in the next video. All right. So up until now, we've spent forever talking about numbers and strings, and you're thinking, oh God, we have so many more to go through and my head hurts already. Well, you know what? I think you're gonna really like this one because this one's really short. And they're called Booleans. And Booleans in Python is bool. And bool, well, there's only 2 options. A bool can either be true or false. That's it. How awesome is that? You just learned Booleans. So a Boolean I can assign to, let's say, my Facebook profile. I can say Andre, or I can say name equals Andre. And make sure that we form this into a string. And then I can say, well, let's say we're creating an even better social network than Facebook. We're creating our own. And this social network also has the is cool option on your user profile. And let's say for now it's false. You see over here that's being highlighted. Now is cool is set to false. But all of a sudden I'm thinking, my profile doesn't look good if is cool is set to false. So I'm going to change that. I'm going to say is cool is now equal to true. Now my profile has been changed to is cool is true. Hooray! And that's it. Booleans represent this idea of true and false, which in programming is kind of like saying 0 and 1. They're logical values, right? There's some logic that we can use, and we'll see when we talk about conditionals in upcoming videos, where Booleans become really useful, because we can use Booleans to control the flow of our program, to do something if something is true, to do another thing if something is false. It's a cornerstone of computer science. And by the way, a topic we're going to explore more and more is this idea of using Booleans to denote logic. So for example, what do you think a bool of 1, converting 1 to Boolean, would do? If I print this and I click run, I get true. In Boolean, 1 means true. A 0, well, that equals false. And remember, we're just simply converting this integer into a Boolean value. And a Boolean, well, is just either false or true. Nothing else. That's it. And I can also convert a string that says true into a Boolean true. Again, this is something we're going to explore a little bit more when we talk about conditional logic. But I wanted to make this video nice and short to let you know that, hey, not all these data types are as complex as, well, numbers and strings. All right, nice and short. I'll see you in the next one. Bye-bye.